Hello, my name is Steven, and together with Anton from Anton Mindstorms Hacks, we've designed this LMS-ESP32 module, and there were some questions about is it possible to make a tutorial just to get started with connecting this module to the Lego Mindstorms and to see how things are working. And this is it, this is the tutorial, and I hope you will find it useful just to see how you get started. The first thing is, I assume that if you receive the module, it's flashed with the latest firmware. If you don't have the latest one, you can get it from firmware.antonmindstorms.com. And if you, I've connected the module. This is CH340. You can see that in the device manager here on the left. And I also connected a Lego Mindstorms module, the robot inventor module, and this is on COM5. So in this case, I can, from the browser, I can connect to the proper module. My Lego Mindstorms is switching off, no problem. I can make a connection, and once it's connected, I can flash it with the latest firmware. I won't do it here because it takes some time, and if that's ready, you can reboot it and you can start programming with it. So I switch my Lego Mindstorms back on. It will show up here, and what I will be using for this tutorial is the Thonny IDE. And one of the reasons I do that is that it allows you to interactively program also the Lego Mindstorms, and that's quite nice, as you will see. It's not for the event, you won't use it for your for the real case, but in this tutorial it's quite nice to use. You have versions for Windows, Mac and Linux, so you downloaded it and you can start it. If you start Thonny, it has a very easy layout. So in the lower part you will see the interactive shell. In this part you can enter programs, and on the left you see the local directory of modules that are loaded in the ESP32 or in the Lego Mindstorms. If you want to use Thonny simultaneously on two different devices, you have to do a setting here in Tools Options, and you have to disable this Allow Single Thonny Instances. Otherwise, you only can do one device at a time. So I can initiate a second Thonny interface. In this case, it's the Lego Mindstorm side, and I have to look for which interpreter I need. So I do run, select interpreter. In this case, I use a Python generic, and see there's a device in COM5. This is my Lego Mindstorms. I connect to it, and what you will see in some cases is that sometimes you have to press Ctrl+C just to stop what's going on. Sometimes you see some values of sensors being printed on the screen. Press Ctrl+C and you will end up in this interactive prompt. And here you can start doing interactive commands. So let's move this to the side. So on both sides you have the left side the ESP module, the right side Lego Mindstorms. Connected both with the special cable. So on one side it is being put into the port of the Lego Mindstorms, and on the ESP side it's connected to the 6-pin serial header. So we have effectively a serial communication between the two devices in both directions. Because we don't want people to low-level program UART interfaces, we've designed a library which is already in the firmware, implemented in the firmware of the ESP module, which you have to install on your Lego Mindstorms. I will show a pointer later where you can find how to install the UartRemote. In this case, it's hidden in this project folder. You see here UartRemote, and the reason for that is that we put it in the project directory is that it survives some reprogramming of the Lego Mindstorms application. Otherwise you have to reinstall it every time again. So let's start by loading the UartRemote library. So what we do is I type the commands in the upper part, and later on we can copy them to the interactive part. So from projects I import all the modules from the UartRemote. On the ESP side I do the same, but I don't need the projects, it's just present there. So let's copy it here. So if this doesn't give an error, it should be alright. Do the same here. And now we have to instantiate an object, like what we call a UartRemote object. And we call it UartRemote, and I can better type it here because I can use tab completion. So I press tab and I will see all the possibilities. In this, on the Lego side, I have to give it an argument, and that's the port on which the ESP module is connected. In this, my case, it's port D. Oh, I made a typo. So this is the UartRemote side, the UartRemote object. I can do the same here, except that I don't need to give it an argument. By default, it uses the proper UART interface. So now I have both sides instantiated. I will put this also in my program here, and I can just do a little test. If I do UR dot and I press tab key, I will see all the methods that are present in this object. And one of the methods I'm going to use is send command. And send command takes as an argument just a string, and that's the command that you want to send over. So let's say test command. I send it over, nothing happens. But it is being sent, and this side I can receive the command, and let's look whether, and it has received the test command from this side here. And you see the second argument is none, and that means I haven't provided any arguments with my send command. If you want to see more details about this UartRemote library, you can go to the UartRemote.readthedocs.io. I will provide a link later on, and there we explain as well as we can how this library works. You see how to receive commands. You will see also the send command somewhere. Is that here? Send command. So how it describes how to use this module. The send command takes as a second argument the way of sending arguments. So suppose I want to send an integer. I could have the easiest way of doing this is to use the wrapper way, and that means that everything entered as a third or fourth or fifth argument is being sent in the exact the same way to the other side. So if I type here 1, 2, 3, I will receive 1, 2, 3 as an argument, as the value. But if I would like to send over an array of values, for instance, that also works. So now it received this array of values. The usual way of doing this is that you say, I take an acknowledge, or if I take the command, and I take an acknowledge, and I see, and I will also receive this. So if I do, because there's nothing being sent, so I send it again. Now we have the command, and I have not the acknowledge, but the value. I meant to use value. So let's do that again. Send it again. And now the value is the array. So this way I can move data from one side to the other. It's completely symmetric. So if I would use the send on this side, Lego, send command, and I would receive the command here, I will get Lego. So this way I can send back and forth. Still, this is not very easy to use, because usually you want on your ESP side you have a sensor, or you have something you want to drive, an LED or a motor, and you want just to do calls from the Lego side to that remote side to instantiate a sensor reading or a motor movement. So the way we have thought to implement it is that we can define functions on the ESP side. So let's say we want to drive an LED, and this LED has 4 arguments: the LED number and the 3 color channels. I don't have an LED hooked up right now, so what I do is just, for debugging purposes, I just print the values that it received. So it's a very simple function. So let's see whether this function is working. The LED 1, 2, 3, 4. It prints 1, 2, 3, 4. So I can check whether this function is being called. Now I have to let the UartRemote library know that it has this function available. The way I do this is to add that function as a command. So take care that in this case it's not between quotes, it's just the function itself. So it knows now that this LED function can be called. And as soon as this is initialized, I can have this UartRemote performing a loop in which it checks whether there are commands received and whether that command is by chance the LED command, and it interprets the arguments that are being passed. So if I do this, you will see that the ESP module is just waiting for commands. So if I now send a command like this, nothing happens because this command doesn't exist. I only have now defined the LED command. So if I do the call function, let's say LED, I know there's something special going on because I want these 4 arguments passed. So I take the wrapper representation and I just set the 4 arguments. So let's see whether it is working, and it's working. So what it does is it sends a command to the other side, the command LED, and it passes 4 arguments. This side is waiting for a command. It checks whether the command is LED, and if that's the case, it's calling the function, and the function is executed. So that is nice, but in some cases you also want to read out the sensor, for instance. So let's try that. It's a little bit to read every time the same value, so it's a little bit boring. So I import a random library and now return random. I'll return a random integer between, let's say, 100 and 200. Now let's check whether the function is working. So I know I get a number between 100 and 200. I have to add that as well. But now I have to take care because this function is returning a value. So this command as a response has to return that value. So I have to define how that value is being sent to the other side. And in this case we use the wrapper representation because that's the easiest. It's not the most efficient one, as you can read in the documentation, but it's the simplest one. In this case I should have 2 commands at my disposal. So let's run this. You can maybe ask yourself what happens if I add a command multiple times, it will get overwritten. So that's no problem. So now it's waiting for a command and it checks whether it's one of these 2. So let's see whether the LED is still working. That works. Now I can call the second command, and that's called sensor. I don't need to give any arguments because I read something from the ESP module. I don't pass any value to it, I only read from it. and in this case it's working. So what we've shown here is that from the Lego side I can send a command to the ESP side, and that command can be either a reading command or passing values. We can also do both at the same time. So let's add a multiply command with 2 arguments, and it returns a times b. So it multiplies a by b and returns that. So we need to add that as well. So this ripper is for the result, for sending back the result, and the a and b are being passed from the Lego side to this function. So we stop this. I can do everything like this. Now let's see whether the sensor function is working. It's still working. The LED is also working. And now I'm quite curious whether the multiply. So now we have a choice in how to pass these arguments. Let's first try this. Let's do something a bit more interesting. 1 and 2. So 4 and 5. And indeed it multiplies these 2 values. Just to give you a little hint about what kind of things you can do here, I also can define more structure based, and you might know the struct library of Python, and it has a description of different types of variables by single characters. In this case, if I say I have an integer, a signed integer. If I say 2i, it will expect 2 signed integers here. So let's see whether that's working. That's working. See whether I can do a minus sign. If I would have do a capital I, that means an unsigned integer. This -4 will get you in trouble. And indeed, it's interpreting it as an unsigned integer while sending it as an int. So this works better. So in this case, if you want to have more performance, it's better to do this dedicated. If you want even more performance, you can also do the war, and then you are up on your own just to send some raw string. And if I do this, it will get very weird because it will interpret the A and the B both as, I don't know what's happening. No, this is not working. Okay, maybe no, because it's a single argument and it's being passed to a function that expects two values. So this is not working. But you can stick to the wrapper, then you don't have to bother about how to pass these variables. So this shows you how to do 3 types of commands. So one is only setting something from the Lego Mindstorms, another one is only reading, and this third one is both sending data to the ESP and getting data back. In a typical case, you would like to store this program on the ESP permanently so that you don't have to enter every time this program. So the way you store that is by using file, save. We have to, before we do that, we have to quit the program, Ctrl+C. So I save the program. Now I have a choice between saving it on the computer file system, so just on my PC, or on the ESP module itself. So if I do MicroPython device, it will get stored here. You will see it on the left side here. Now there's a special name that you can use, and it's called main.py. And the main.py gets executed automatically if the module restarts. So that's an ideal way of doing it, because if I restart the module, if I hook it up to the ESP, I know that this program is already running. So let's try that. So I save this program. I have debugged it completely because I know that it's working. And now I can reset the module. And you will see the result of the reset here. And it starts running in this loop. I don't see anything. I could have printed something of my program is running, but I don't do that. And now all these commands should work, and it's indeed the case. And of course I've now used just like dummy functions, but in reality you would, in these functions you would connect to devices, to real motors or LEDs or sensors. And that's something for the next video. I will show you how to hook up an I2C sensor and read it from the LEGO Mindstorms side. So that's about it. Thank you for watching.